Hello and welcome to this video brought to you by Smart EduHub Mumbai. In today's video, I shall be explaining to you indices. There are certain laws of indices which you should keep in mind. 4 laws have been mentioned on the screen. First law is a raised to m into a raised to n is equal to a raised to m plus n. The second law is a raised to m upon a raised to n is equal to a raised to m minus n. The third is a raised to 0 is equal to 1. And the fourth one is a raised to m the whole raised to n is equal to a raised to m into n. Now I shall explain to you the meaning of these 4 laws. For example, about the first law, you can apply it to numbers. That means a can be replaced by numbers, m can be replaced by numbers. That means every alphabet can be replaced by numbers. But when it is written a raised to m into a raised to n, it means that both the a's should be same. That is, both the numbers should be same. For example, if I say a raised to 5 into a raised to 4, that is equal to a raised to m plus n. So 5 plus 4, which is equal to a raised to 9. If I use another example, for instance, I say that 10 raised to 2 into 10 raised to 8 is equal to 10 raised to 2 plus 8, which is equal to 10 raised to 10. Now, when will this law not apply? This law will not apply if you take 10 raised to 5 into 8 raised to 2. See, here the bases are different. The rule is what? The bases should be same. That is what the rule means. When they write a raised to m into a raised to n, they are trying to tell us that the bases are same. If the bases are same, the rule does not apply. So you cannot use this rule. So rule cannot be used. Right? Now, moving ahead to the next law, that is a raised to m upon a raised to n. So if I have a raised to 5 upon a raised to 4, that becomes a raised to 5 minus 4, that is equal to a raised to 1, and that's equal to a. Now, if you take, instead of a, you take a number like 10 raised to 2 divided by 10 raised to 8. Again, it says a raised to m upon a raised to n, meaning the bases have to be same. The bases are same. So the rule can be applied. So this becomes 2 minus 8, that is 10 raised to minus 6. Again, you cannot apply this rule when the bases are different. So that means if you have something like 10 raised to 2 divided by 5 raised to 8, you can't apply the law. Why? Because the bases are different. The base is 5 here, the base is 10 here, so you can't apply. Okay. Taking the example of a raised to 0. A raised to 0 equals 1 means that you can take 5 raised to 0, it will mean 1. You can take 100 raised to 0, it will mean 1. You can make b raised to 0, it is 1. Meaning you take anything raised to 0 is going to give you a 1. And over here, a raised to m the whole raised to n. So if I have 10 raised to 2 and that raised to 5, according to the law, it is 10 raised to 2 into 5, which is equal to 10 raised to 10. Similarly, if I have b raised to p the whole raised to q, the final answer is b raised to p into q. So this is how you will be interpreting these 4 laws, right? Let us solve past paper questions, right, from IGCSE. And I've taken them all from paper 2 0580. This question has been taken from May June 2002, and that's question number 14, that's paper 2. So write down the value of x raised to minus 1. Okay, now x raised to minus 1 means, let me do the rough work here. The first one I'm solving, x raised to minus 1. X raised to minus 1, our x is 1 upon 4. So 1 upon 4 raised to minus 1. And what is that equal to? That is equal to 1 upon 4. Okay, and how to solve it without a calculator? 1 means 1 divided by 1, and 1 divided by 1 divided by 1 upon 4. So that means it is equal to 1 upon 1 into 4 upon 1, which is simply 4. Okay, now solving the next one. Okay, so second one is x raised to 0. Now you know any number raised to 0 is 1. So even if it is 1 upon 4 raised to 0, you're finally going to get 1. So this answer is going to be obviously 1. Now going to the next question, and that is x raised to half. Now our x is 1 upon 4. So x raised to half, meaning 1 upon 4 raised to half, and anything raised to half means the square root of that number. So I have square root of 1 upon 4, and I know square root of 1 upon 4 is half. Also the last one, and last one says x square. Now our x is what ideally? X is 1 upon 4. So x square means 1 upon 4 square, which means 1 square upon 4 square. That's if you're wanting to simplify, if you don't understand that. So 4 square is 16. So this means it is 1 upon 16. So that is how you solve the 14a part of the question. Then they are telling you, write y raised to minus 1, y raised to 0, y raised to 2 and y raised to 3 in the increasing order of the size when y is less than minus 1. So if they're telling you y is less than minus 1, we'll take y as being what? I can take y as being minus 10 also. So suppose I take y is equal to minus 10. Why am I taking a number? I need to actually compare these. So if I take a number, it becomes easier. So y raised to minus 1 means what? Y raised to minus, I'll substitute the value of y here. So that becomes minus 10 raised to minus 1, which is 1 upon minus 10. Okay, and 1 upon 10 is 0.1. So 1 upon minus 10 is minus 0.1. That is your first number. Now they're telling you y is y raised to 0. So if we have taken y as minus 10. So minus 10 raised to 0 is 1. Then the third one is y square. Y is minus 10. Minus 10 square is 10 into 10 is 100. Minus into minus is plus. So this becomes 100. Then you have the fourth one as y cube. That means minus 10 the whole cube. And minus into minus is plus. Plus into minus is minus. And 10 into 10 is 100. 100 into 10 is 1000. So we have to list from the smallest, right? Now you know the larger the number with the negative sign, the smaller it is. So we have two numbers with negative sign. One is minus 1000 and one is minus 0.1. So minus 1000 is y cube. So our y cube is the smallest, followed by y raised to minus 1. Then comes y raised to 0. And the last is y square. So did you see what I did? I actually took a number. It's difficult to visualize. So I took a number and I substituted that number as the y value in all the examples, like y raised to minus 1, etc. and then I compare the answers and I put them in the order. Okay, so let's take another example. Okay, this question is from May June 2004, that's paper 4 and question 4, sorry, and simplify. So here we have to multiply meaning we can take the rule a raised to m into a raised to n, which is equal to a raised to m into n. Now let's see how we can use this rule. So first it is 2 upon 3 p raised to 12 into 3 upon 4 p raised to 8, which is equal to, now what we can do is we can separate the numbers out. So it becomes 2 upon 3 into 3 upon 4. Then we can write the variables. So this is p raised to 12 into p raised to 8, which is equal to 3 gets cancelled, 2 1s are 2, 2 2s are 4. So it is half into p raised to 12 into p raised to 8. Now here you can say a raised to m into a raised to n is a raised to m plus n. So it is p raised to 12 plus 8 is 20. So your answer is half into p raised to 20. Okay, let's take another example. This question is from May June 2008, paper 2-1, and it's question number 8. So this looks like the form a raised to m the whole raised to n is equal to a raised to m into n. So let's see how we can use this. 27x cube the whole raised to 2 upon 3. So the first thing is, let us ask ourselves, can we write 27 in some number raised to a power? Yeah, 3 3s are 9, 9 3s are 27. So this is 3 raised to 3, and I can separate out raised to 2 upon 3 and x raised to 3 the whole raised to 2 upon 3. 3 3 gets cancelled, 3 3 gets cancelled. Therefore we have 3 square into x square, which is equal to 9x square. Okay, let's take another example. Okay, this question has been taken from May June 2008, that's paper 2-2 and question number 8. Again, this looks like a raised to m the whole raised to n is equal to a raised to m into n. So let's see how we can apply this rule. So let's separate the number and the variable. So 16 raised to 3 upon 4 into x raised to 4 the whole raised to 3 upon 4. 4 gets cancelled. So 16 can be written as 2 raised to 4. I can do that, yes. Why I'm writing it as 2 raised to 4 and not 4 raised to 2? Because so this question has been taken from May June 2008, paper 2-2, and that's question number 8. So let's separate the number. So 16 raised to 3 upon 4 into x raised to 4 the whole raised to 3 upon 4. 16 we can write as 2 raised to 4. I'm writing it as 2 raised to 4 and not 4 raised to 2 because my 4 will get cancelled if I write it in this way. And from here the 4 gets cancelled, so it's x raised to 3. Simplifying it further, 4 and 4 gets cancelled, so it's 2 raised to 3 into x raised to 3, which is nothing but 2 2s are 4, 4 2s are 8, 8x cube. Okay, now let's solve another example. Now this question has been taken from May June 2010, paper 2-2, and that's question number 5. So now we have to write 2 raised to 8 into 8 raised to 2 into 4 raised to minus 2 in the form 2 raised to n. That is, we have to have a base which is equal to 2. So let's change all the numbers with bases equal to 2. So the first 2 raised to 8 we need not change, is already having a base of 2 into 8 square. We need to change that 8 into 2. So 2 raised to 2 is 4, 4 into 2 is 8, so 2 cube. So we can write this as 2 cube square into 4 can be written as 2 square the whole raised to minus 2. So now we get 2 raised to 8 into 2 raised to 6 into 2 raised to minus 4. And if I use the formula a raised to m into a raised to n, I get a raised to m plus n. So it's of the same type, so we can use this as 2 raised to 8 plus 6 minus 4, and that gives us 2 raised to 6 minus 4 is 2, 2 plus 8 is 10. So we have it in the form 2 raised to n, where n is 10. Here's another example from May June 10, paper 2-3 and question 6. 3 raised to x into 9 raised to 4 is equal to 3 raised to n. So we want to find the value of n. So that's only possible when we have the bases to the left and bases to the right as 3. Okay, because when the bases are all equal, we can forget the bases and equate the powers. Now 9 can be written as 3 square, and then we continue as it is. This becomes 3 raised to x into 3 raised to 4 into 2 is 8 equals 3 raised to n. So now left hand side has 3 raised to x into 3 raised to 8. That is of the form a raised to m into a raised to n. So that is equal to a raised to m plus n. So it is equal to x plus 8 equal to my right hand side, which is n. Like I told you, if the bases are equal, forget the bases and equate the powers. Therefore we have x plus 8 equals n, and therefore you can either say n is equal to x plus 8. Yeah, we in fact need that. We don't need x is equal to what. So fine, we got our answer. And let us take one more example. Okay, and I decided to take a last example. And the third one, I'm taking this third question from May June 2011, paper 2-1. And I wanted to call it as my last question, but it looks like a very interesting question. So I'm really glad that I chose this as my last question. And one more you can see below, May June 11, paper 2-1, and fourth question also is from indices. I'll explain that to you, but I'll do the above example for you. Now we want to find out what is 81 raised to 0.25 divided by 4 raised to minus 2. So we know the rule applies only for a raised to m divided by a raised to n. That means my bases a's have to be the same. So my job is first to see how I can make the bases equal. So first what I'm going to do is I'm going to write this 81 into something. Okay, let me see what I can do. But 0.25 means 25 divided by 100. Okay, so divided by 4 raised to minus 2. See, I've not even found the method. I'm not doing it in front of you directly. I'm just trying to think afresh. Even I've not seen this sum. Okay, so let's see how we can solve this. Now 81 is what basically? 81 is either 9 square. Okay, so that means I can do 9 raised to 2 the whole raised to 25 upon 100. Okay, and the whole thing raised to divided by 4 raised to minus 2. Okay, so now 2 ones are 2, 2 into 50 is 100, 25 ones are 25, 25 twos are 50. So that means I can rewrite this as 9 raised to half divided by 4 raised to minus 2. That means square root of 9 divided by 4 raised to minus 2. And square root of 9 is 3. 3 divided by 4 raised to minus 2. Now, to tell you what this will simplify to, I need to erase this and use this space available here. So excuse me for that. Okay. So what I'm going to do here is I'm going to change this into a further reduced form. So 3 divided by 4 raised to minus 2 is 1 upon 4. And like I told you, when there is no denominator, it means 3 upon 1. This 3 upon 1 divided by 1 upon 4 means 3 upon 1 into 4 upon 1, which is 3 into 4, which is 12. So the answer here is 12. Getting it? And I also do the last one. I said this was the last one, but I'm tempted to even solve this one. So let me really solve this. So you need to find m, and it's pretty simple. 4 raised to m into 4 raised to 2 is equal to 4 raised to 12. Now this is like a raised to m into a raised to n. So my left hand side changes to 4 raised to m plus 2 equals 4 raised to 12. Like I told you, if the bases are equal, ignore the bases and equate the powers. So I have m plus 2 equals 12, or I have m equals 12 minus 2, which is 10. So my m is 10. Fine. So that's all in today's video on indices. And as you can see, I have solved the questions from 2002 to 2011. Okay. So you can do the same thing. Always see, whenever I'm explaining through videos, you can copy the questions and try solving them with me. That will help you to understand better. And in case you don't understand something, please message me and I shall make videos for the same and upload for you. So thank you all for watching my video. Do subscribe to my channel if you like. Thank you.